Okay, today's video. Hey, still working on my studio. Probably next week, and then like I said before, we'll get some better sound and better lighting, so you can see things a little bit better. Um, Hope you're just about through chapter 2, but I wanted to continue on with linear equations where we left off the last time you watched the video. And it's really important that you watch these videos because I may include information about exams and material that you should emphasize. I mean, I'd like you to read everything, but some things definitely are more important than others as we go through these chapters in the book. So we left off with problems like this. And what I mean by like this is it's a linear equation. The highest power of x is a 1. So it's more what you don't notice. You don't see x squared. You don't see x cubed. You don't see a cube root. And you don't see any trigonometry or logarithms. But more specifically, where we left off is where I had said when you see the distributive rule, do the distributive rule. And in a way, I don't even ask why I do it as a reflex. I do it as a habit. There's the potential, the possibility to do the distributive rule, and so I do the distributive rule. So let's go ahead and do that. Then we look at this and we say, oh yeah, that's that kind. Yeah, I already know how to do that kind. We did that kind, or I've done that kind many times. So we'll add 5 to both sides. And then we'll divide both sides by 10. Okay, fine. And of course, well, I cannot resist doing this. We need to do one with fractions, just because I see people all the time, and they'll do this, no problems, and they won't even hesitate. But I can't wait to get this board affixed properly. But if you have, let's say, you know, something like that, people will freeze in their tracks. I mean, if you don't, good. That's, like I keep saying, that's fantastic. If you have fractions under control, then I'm not talking to you. In a way, you should feel fantastic and great. But if you're like most people, as soon as you see the appearance of fractions, it causes you to hesitate or freeze or not feel confident or become anxious. Nonetheless, I'm going to do this problem the same way. So we'll do the distributive rule. So this times this. And then, of course, 1 is sort of nice, right? Anything times 1 is just itself. And then we'll add 4/7 to both sides. We get that. From here on out, I know I keep saying this, but from here on out, I added 4/7 to 1/2, and I didn't quote unquote show my work, and I'm not going to be showing my work, but you should confirm for yourself that 1/2 plus 4/7 really is 15/14. If you could, like I said, if you could do it in your head, do it in your head. If you need to go off on a piece of scratch paper, let's see if this can be seen here. Go off on a piece of scratch paper, 1/2 plus 4/7, and again, add it however you see fit. I'm going to use that method that I guarantee to you in one of the earlier videos would always work, because it will always work. And 7 plus 8 is 15. Fine. You should be doing this either on paper or in your head every step of the way. Or even here, 4/7 times 14. Is 4/7 times 14, is it really 8? There's a 1 under there. 7 goes into 7 once. 7 goes into 14 twice. So it's 8 over 1, which is 8. Okay, fine. I find that it's critically important that you confirm each step as we go along, or as I go along, or if you're looking at a video online on YouTube or wherever, or reading examples in the text. So you're reading an example in the text and you see this, and then you see this 8. You should know where the 8 came from. In fact, you should have calculated that yourself. At any rate, here, let's go ahead and divide by 8. Sort of an unpleasant. Now this is interesting right here, and I get it, and it affects me too. Okay, so what's 15/14 divided by 8? Well, there's a 1 under there, and you flip it and multiply. So I have to multiply 8 times 14. Now, if you were all here, I would ask you, what is 8 times 14? Because I don't walk around knowing what 8 times 14 is. This is kind of interesting. This is a case where you could use a calculator. I find a calculator a lot slower to use. But in this course here, I guess to some extent, I am interested, but I'm not really supposed to be interested in how it is that you do 8 times 14, but you get 112. Now, look at this answer, 15 divided by 112. That will check your confidence because it quote-unquote looks strange. It's not strange. It's a perfectly fine number. There's nothing wrong with it. In fact, it's ordinary and typical and nothing surprising. But if you're used to answers always coming out where the answer is 3, or the answer is 2/5, or the answer is 1/2, or the answer is 8, this can be jarring to see. But this is typical. As a matter of fact, like I said in one of the earlier videos, if you took a number line, let's say there's 0, 1, 2, 3, and so on and so forth, and let's just circle a region here between 1 and 2. How many whole numbers do you see in the region I circled? 2. How many fractions? An infinite number. How many quote-unquote, or so to speak, nice fractions, or fractions that you would feel happy to work with? Well, I guess there's 1.5. That's pretty nice. And maybe 1 1/3, 2/3. The quarters, so 3/4, or 1/4, or 3/4. The fifths. Most of the fractions in this region are not at all nice. In fact, this is even relatively nice. So don't be surprised when you see answers or numbers that look like this. Particularly this problem here, I just wrote down each of these numbers, 4 7s, 14, and 1 1/2, more or less at random. Sure, I wrote these two numbers down so we would get some cancellation and things wouldn't get too out of hand. But this is pretty typical. Don't be shocked when you get answers like this. It doesn't mean your answer's right. I could have made a mistake in here. I'll never make a procedural mistake, but careless mistake. I actually like the fact that I make careless mistakes because in class, again, if you were all here, I might make 1 or 2 careless mistakes every day, and then I would see who's really paying attention because you would raise your hand and say, "Wait, that's wrong," and that's great. Well, that's not really possible right now. Maybe once I get Zoom going, which looks like it'll be next week, and I'm going to start having some office hours, then you can absolutely do that. You could say, "Wait, stop," and chime in, and so on and so forth, and that'll be good. Now, what next? Well, what next is, and I know you've probably heard this sort of thing before. Well, if I said I had 5 apples and 2 oranges, 5 apples and 2 oranges, what do I have all together? 5 apples and 2 oranges. I don't know what else you could say. I don't have 7 apple oranges or anything like that. Well, if I have 3x plus 2y, and I ask you, what does that equal? All you can really say is, well, you have 3 x's and 2 y's. What else could you really say? However, if I said you had 3 x's and 2 x's, you certainly could say, well, that's 5 x's. Furthermore, if I said we had 3 x's, like 3 apples, and 2 y's, maybe 2 oranges, and then to that I added 7 x's plus 10 y's. Again, you could think of this as 3 apples plus 2 oranges, plus 7 apples plus 10 oranges. I mean, if these objects were actually in front of you and you saw 3 apples and 2 oranges and 7 apples and 10 oranges, and I asked you what we had all together, I think you would spontaneously group the apples together and group the oranges together. Or 3 cats and 2 dogs, 7 cats and 10 dogs. You would tend to automatically or very naturally group these similar objects together, or these like objects together. So this is called adding like terms, or at least that seems to be what most people call this. So here we'd have 3 x's plus 7 x's is 10 x's, and 2y plus 10y is 12y. And this idea of adding like terms, along with the distributive rule, whenever I have the opportunity to add like terms, I add like terms. I don't even question why I'm doing it. If there's a possibility, an opportunity, if I can add like terms, if they're there to be added, I do it. And I don't ask why. It's almost always, like I said, a step in the right direction. If nothing else, it simplifies things. And if things are a little bit simpler, then maybe you can figure out where to go from there. Now, that said, let me go ahead and up the ante, so to speak. Let me up the level of difficulty on these equations from what we just did previously. Well, let's do something like this. Now, I'm sure you've done equations like this before, but not in this course. So I'd like to look at this and say, hey, this is the first time we've ever seen anything that looks like this. So how should we proceed? Well, at first, I don't know, but I do see that I can do the distributive rule. So while I'm thinking what else to do, maybe I don't know what else to do. Hey, so while I'm killing time, I'll do the distributive rule. And that's what I meant by doing the distributive rule by force of habit. It's there. I can't resist the urge to do the distributive rule, even if I don't know why I'm doing it. So I'll go ahead and do it. So 12x plus 3 plus here. Hey, these wavy lines, they don't really mean anything. To me, they're just a way of visually calling attention to the distributive rule. You certainly don't have to put those wavy lines in there. 10x minus 15 equals 8. Okay, now what? Well, I have the opportunity to add like terms. So even if I have no idea how to continue this problem, let me go ahead and add like terms. So 12x plus 10x. I see this bracket here. That doesn't mean anything either. This is just my personal way, I mean, other people do it too, of calling attention to the like terms. I'm sort of saying, here are the cats, here are the dogs, here are the apples, here are the oranges. Do you have to make this? Not at all. By no means do you have to do that. You don't have to do anything. Or you can come up with your own method of grouping like terms. But 12x plus 10x, 22x, and 3 minus 15, these are just plain numbers. 3 minus 15 is negative 12. And then here we go again. This is that general form of a linear equation. Ax plus b equals c. So this should become like a friend when you see this. You say, oh, yeah, no problems. Take a nice deep breath and finish the problem. Let me add 12 to both sides. And I'll divide both sides by 22. And I may never be able to resist pointing this out, but I think I will. But notice I've reduced my fraction, my answer. If I hadn't, it would still be correct. It's just annoying. Like if I owe you $5 and I give you 500 pennies, well, 500 pennies is $5, but wow, is that annoying. And in fact, you may refuse to accept it, and that's why some teachers refuse to accept unreduced answers, and I can hardly blame them. I would accept an answer which is unreduced, but it's annoying. And just unnecessarily difficult. And certainly this is easier than 20 or 22, although in this case it's not particularly, there's not a particularly big difference between both of them. Now, let me do one more example like this, because this is rather important. But let's say we have 1/2 times 6x minus 1 plus, 4/5 times 2. Now, when I'm hesitating there, I guess I should tell you that I am writing these numbers down in a random fashion, but not quite. If I truly wrote down random numbers, the numbers might get out of hand, and we might feel really compelled to reach for a calculator. And that's not the point here. The point here is not that you are the human calculator or that you have a calculator at hand. The point is really the procedure to solve the equation, not crunching some awful numbers. So when I picked this number 2 here, I could have picked 37 or I could have picked 419, but then we might want to reach for a calculator. We'd have some real challenges doing some mental arithmetic here. Let's just say plus x equals, how about 1/2 x minus 1? And again, you might have done an equation like this in your life. You probably have, but we haven't in this course. So right now, I would like to look at this and say, I've never seen an equation like this before. So what do I do? How can I figure it out? Well, I could stare at it for a long, long time. On the other hand, I see the opportunity to do the distributive rule. So let me do that. Hey, maybe after I do that, I won't even know how to proceed, but at least, that gives me something to do is better than nothing. So I'll go ahead and do this times this. Remember, the distributive rule is just 2x of multiplication. Regular multiplication, nothing special, nothing different, just multiplication, but it has to be done. So here, 3x minus 1/2, and then here we'll do this times this, and this times this. So plus 8/5 plus something I hadn't pointed out, you're probably aware of, but hey, you have a cat. That's one cat. A car, one car. A dog, one dog. A chair, one chair. A person, one person. X. There is a 1 hiding out there. Can you write the 1 down? Sure. Do you have to? Most people don't. I don't. So no, you don't have to. But you can if you want. So in front of every letter all by itself, whether it's an X or a Y or an A or a B, there is always a 1. It's just like there's a multiplication. I mean, it is 1 times X. It feels very strange to write that there because nobody really ever does. But yeah, it is. And same thing here. It's 6. This is going to feel very odd for me to do this. That actually feels remarkably odd. The 6x really is 6 times x. Wow, that feels strange to write that down because nobody ever does. At least I never do. But 6x means 6 times x, and 1x means 1 times x. At any rate, what's 4/5 times 1? Well, that's kind of nice. 4/5. Sorry, this wiggly wobbly board right now. Like I said, we'll get this remedied pretty soon. But 4/5 x equals. Now this over here, maybe at first I don't know what to do with it. So let's just bring it along for the ride. We're not sure what to do with it yet. What next? Well, there's the possibility of adding a like term. So let me do that. Why? I don't know why. It's other than that. Maybe I don't know what to do. So I'll at least do something. So let me add like terms. So 3x plus 4/5. Again, I'm going to have to get used to this online stuff because if you were all here right now, I'm going to tell you what you would see me do is I would say 3 plus 4/5, and I would wait. And what would happen is I would start to see who has developed fluency, who's developed skill at dealing with fractions, and who maybe needs to work on it. Or, if you can't do 3 plus 4/5, then you're going to be blocked. You won't be able to proceed and complete this problem. So it's a skill you just have to have. I'm not saying it's fun, because I really don't think adding fractions is fun. But you have to be able to do it, and you have to be able to do it without causing yourself too much stress or anxiety, and that's just as a matter of practice. Okay, so 3 plus 4/5, 19/5 x, and then we have negative 1/2 plus 8/5. Again, I should have a little pause right now. Everybody figure that out. Now, the pause that I had, here's an interesting question. How long should it take you to do that? Gosh, I just did that twice and forgot it twice. I'll have to do it again. Hey, I don't know what negative 1/2 plus 8/5 is. I mean, how would I know? I don't walk around knowing that. But I guess I take a look at it and I think, okay, that's 11/10. Maybe I want to double check that again. How long should that take you to do? And the answer is, I don't know. There isn't really an answer for that. There isn't an officially recognized time limit by which you should have this done. But if adding these two together takes you 3 minutes, that's not wrong, but wow, that's a long time. And if this took 3 minutes and this took 3 minutes, then this whole problem could wind up taking an hour and a half. Now, it's taking a long time because I'm talking a lot as I'm doing the problem. Math is not a race. It's not a matter of can you get it done quicker than the next person. But a problem like this really shouldn't take a half an hour. It really shouldn't even take 15 minutes. Like I said, there's no internationally recognized time limit by which time you should have this problem done. But we should be able to move along pretty quickly. Now, notice I've got x's on both the left and the right side, and as a general rule, we'd like to get the x's on one side. I went like this because I read left to right. I guess I would like my final answer to say x equals. But that's not necessary. If A equals B, B equals A. If X equals Y, Y equals X. So the left and the right-hand side of an equation, you can always interchange them. You can always switch them around at your discretion anytime you want. That said, I probably have a tendency to want to get the X's on the left. Now, I'm going to misspeak, and I'm going to continue to misspeak. I'm going to say, let's get this 1/2 X over here. That's not what we're really doing. What I'm really doing is I'm going to subtract 1/2 X from both sides, because you need to do the same thing to both sides. If you're going to add, subtract, divide, or multiply, get is not a mathematical operation. If you have a calculator nearby, again, if you were all in class, and most of you would probably have calculators, I would say look at your calculator. Calculator has an add button, a subtract button, a divide, a multiplication button, all kinds of other buttons, sine, cosine, tangent, logarithms, exponents, who knows what, all sorts of fancy buttons and menus. But get isn't one of them. So when people say, let's get this or move this 1/2 over here, move isn't one of the buttons on your calculator. That's not what's really going on. But it kind of feels that way. Here, let me go ahead and do this. Now, look at this right here. Again, as far as checking your confidence, 19/5 minus 1/2. For me to write it like this feels awkward. I don't normally write it like that. And it does feel a bit awkward. Normally, I wouldn't write this at all. So for me, writing the negative 1/2 makes it more difficult, not less difficult. In my mind, right here, I just feel compelled to point this out. When I was a little kid in elementary school and they taught us to do fractions, certainly I was taught, this is going to feel really strange for me to write it like this, but I was taught, wow, that feels weird, to write it like this vertically. Why do I say weird? Because I personally don't ever do it this way, and I don't think of it this way in my mind. If this is the way you think of it and it works good for you, stick with it. You want to find a way that works for you, and like I said, that doesn't cause you too much stress. This right here actually causes me a fair amount of stress because I find it awkward and cumbersome in my own mind's eye, which is difficult to really elucidate what's going on in anybody's mind. Nonetheless, this is the way I tend to think of it. And I can tell you, for me, what I tend to think of is, what's 9 times 2? So 38. So somewhere in my mind's eye, I lodge a 38. It's difficult to say whether it's visual or verbal, but I sort of think, okay, 38, and then I know the common denominator will be 10, so I guess I don't worry about that temporarily. And then 5 times 1 is 5. So 38 minus 5 is 33. And then I say, oh yeah, that's right. The common denominator will be 10. Now this is essentially what I'm thinking. You may be thinking something completely different, and that's fine, but no matter how you slice it, the answer here is 33 over 10x. I want to get plain numbers over on the right-hand side sooner or later, so let's go ahead and do it now. Let's subtract 11/10 from both sides. Now, this is getting pretty messy looking here. So let me show you how I will normally write it. I won't normally write that down. I'm going to keep saying this. Can you? Yep. If it works for you, please, please do it. For me, I'm thinking I'm going to subtract 1/2 x from both sides. Okay, here's what I'm really thinking. Let's get this over here and this over here. And that's what I think. And that's what I might say. Although technically that's not really what's going on. I'm subtracting 1/2 x from both sides, and I'm subtracting 11/10 from both sides. So what's negative 1 minus 11/10? So again, here's where you should be figuring this out. So maybe here's my proverbial scratch paper over here. So negative 1 minus 11/10. I mean, try that right now. I know it's morning. It's maybe first thing in the morning. And your mind, if you have a mind like most human beings, doesn't want to do that. It'll fight you on this. Your brain will fight you on this. Your brain will say, I don't want to do that. Well, this is the key thing. And once you really get in the habit of doing this, I think the rest of everything will flow fairly smoothly. So think about that for a minute. And what do you get? Negative 21 over 10. Now, just one more step to go. We don't want to keel over before we finish the problem. Now, as the numbers, I'm going to sound like I'm contradicting myself. As the numbers get bigger, at some point, I do start writing things down. And it's really just a moment-to-moment, day-by-day decision that I sort of quickly make normally whether or not I'm going to write this down. So we want to do this final division. If I were working this out by myself, without anyone watching me, I can show you what I would do. I'm hesitant to do this because what I'm really going to do is divide both sides by 33 over 10. How do you divide? You flip and multiply. When I flip this over, we'll get 10 over 33 and 10 over 33. The 10s will cancel out, the 33s will cancel out because any number, of course, divided by itself is 1, so we wind up with x. So that's kind of a done deal. What will I have over here? Well, I'll have negative 21 over 10 times 10 over 33. Now you notice I didn't plan this out, but I'll take advantage of the fact that we get some really nice cancellation going on here, right? 10 goes in 10 once, 10 goes in 10 once, and lo and behold, 3 goes in here 7 times, and 3 goes in here 11 times. So we had x equals negative 7 over 11. Let's see if that's visible on screen. Oh, not. So, well, there, negative 7 over 11. I could just chop my head off. I guess it's not really necessary right now. Okay, how many? We're 26 minutes into this. So maybe that's good enough for this particular video. Seems to me there was one other thing I wanted to mention. Well, yeah, and here's the idea, is how difficult can these linear equations get? And the good news is not much more difficult than this. There's one additional type. I mean, these don't have names. I mean, it's not like the problem I just did. It's not type 13A. But nonetheless, there is one other type of problem. And I'd like to go over it in the next video. So not in this video, but let me just go ahead and write it down. And what I'd like you to do is you try doing this. Try doing this. Don't look for outside help. And if you've seen this before, okay, fine. But anyway, just try this. In the next video, I'll go over the same problem. So here we go. 3 times 2x minus 1 divided by 5 plus 2 times, let's say, 4 plus 3x divided by 6 equals x divided by 2 plus 1. And the bad news is, if you've never done this before, this looks complicated. But the good news is, this is about as bad as it gets. About as bad as it gets. So try doing this problem. Like I said, just without a calculator. Don't go to YouTube. Don't even look at your textbook. Just try doing this problem. And then on the next video I post, will either be later today or tomorrow, I'll go over this. And we'll see how you did. And there's definitely many ways to do this. And I'm going to show you a way that maybe you haven't thought of before. Maybe you haven't done before. Maybe you do think of it. I don't know. Okay, so that's it for today.